Okay, guys, we're getting into day 2 of Unit 8B. So let's get to it. We are adding and subtracting rational expressions. And if you remember, rational expressions are ones that we can write as fractions. So let's get into the steps. Step 1. First thing we are going to do is find a common denominator. Next step, we're going to multiply numerator and denominator of each rational by what they are missing from that common denominator. And step 3, we're going to simplify the expression that we get. So next, let's get into some examples. Let's actually do this instead of talking about it. All right, so first up, we're going to simplify these expressions. So we have 4 over 3x minus 2 over x squared. So if you notice here on this side, we have the 3 and the x. Over here, we don't have the 3, but we have the x squared. So in order to take everything into account, our common denominator needs to be 3x squared. So what's missing here? We're missing an x. So we're going to have to multiply both sides by x. Here, we're missing a 3, so we're going to have to multiply numerator and denominator by 3. So what that looks like is this. We're going to have 4 over 3x. This is going to be times x over x, because this was missing an x, minus 2 times, 2 over x squared times 3 over 3. This is going to give us 4x over 3x squared minus 6 over, sorry, there was a square there, over 3x squared. So this means we are going to have 4x minus 6 over 3x squared. Now the last step is we look for anything we can cancel. Here, we could factor out a GCF of 2. This is going to be 2 times x minus 3 over 3x squared. Since we can't simplify it any further, that is going to be our answer. Next, we have 4 plus x plus 2 over x minus 3. Now, there is no denominator here. There is a denominator here, so our common denominator has to be the only denominator. So we are going to multiply this 4 times x minus 3. So we will have 4 times x minus 3 over x minus 3 plus x plus 2 over x minus 3. Now in order to see what we can combine, we're going to have to distribute this 4. So that's what we're going to do. So this is going to give me 4x minus 12 plus x plus 2 all over x minus 3. So once we have that common denominator, we can start putting them together. All right, now we're going to combine our like terms. We've got 4x and x, and we have 12 and 2. Those are our like terms, so we combine them. 4x plus x is going to give me 5x, and then negative 12 plus 2 is going to give me minus 10. We are still over x minus 3. Now, what we can do up top is find a GCF. That is going to be 5, and what we're left with is x minus 2 over x minus 3. Now, nothing in here is going to simplify or cancel, so we're done with that. Okay, next we have x, and we have x plus 2. These have actually nothing in common, so the only possible common denominator is those two things multiplied together. So to get that, we're going to have 2 over x times x plus 2 over x plus 2 plus 1 over x plus 2 times x over x. So for each one, we are multiplying by the thing that it did not have in the denominator. So this is going to be 2 times x plus 2 over x times x plus 2 plus x over x times x plus 2. So we're going to distribute this, And we're going to actually perform the addition here. So this will be 2x plus 4 plus x over x plus 2. And this will be 3x plus 4 over x plus 2. Now, neither of the, I'm sorry, this is all times x, because we can't drop this term here. Now, there's nothing here that cancels, and we can't factor out a GCF, so this one is also done. Now, our next example, and we're going to start speeding this up a little bit, because here, this and this have nothing in common. So we are going to multiply each of those numerators times the thing that they are missing in the denominator. This will give me x times x plus 4 over x minus 1, x plus 4 minus 3. Now what this one is missing is the x minus 1. And this will be over x minus 1 times x minus 4. Now we can start combining these, and we are also going to distribute so we can find our like terms and maybe cancel. So over here, on this side, I am going to have x squared plus 4x over x minus 1 times x plus 4. We don't need to distribute those yet because we may be able to cancel later. This is minus 3x minus 3 over x minus 1 times x plus 4. Now, we're going to get this all under the same fraction, because now we have our common denominators and we've distributed, so we can do that. So I will have x squared plus 4x minus, careful here, 3x minus 3. This whole thing is in parentheses, and it is being subtracted. Not just the 3x, the whole thing is being subtracted. That is over x minus 1 times x plus 4. All right, so we've got a little more work to do. All right, this is going to be x squared plus 4x minus 3x plus 3 all over x minus 1 times x plus 4. Time to start combining our like terms. X squared is by itself, but we have the 4x and the minus 3x. All right, so that is going to give me x squared plus x plus 3 over x minus 1 times x plus 4. So now what we could potentially do is factor this numerator and look for places that we might be able to cancel. So if I were to do that, this would tell me that that is going to be the same in my binomial pair, and this would mean that they're both positive. I would have to have things that multiply to give me 3 and add to give me 1. Well, there are no such combination of things, so that doesn't factor. And if it doesn't factor, it can't cancel. Remember our little slogan from last time, no cancellation without factorization. So that means we're done here. Let's look at the next one. Okay, so again, there's nothing in common between our denominators. So our common denominator is those two things multiplied together, which means we have to multiply this numerator by this denominator and this numerator by this denominator. So let's get started with that. This is going to give me 4 times x plus 3 plus 6 times x squared, and this is all over x squared times x plus 3. So now we're going to distribute this 4, and then we're going to look for common terms. So we have 4x plus 12 plus 6x squared over x squared times x plus 3. Now we might have some things we can cancel, and honestly, I don't really love the way this is looking. I like to have things in order. So let's just rewrite it in order. So we're going to have 6x squared plus 4x plus 12 over x squared times x plus 3. Now I want to factor this numerator. First thing that I am going to look for is a GCF. And I notice that I've got 6, 4, 12. Those are all divisible by 2. So I can factor out a 2 and then see if what's left can also be factored. I'm going to pull this up here, give myself a little more room. This will be 2 times 3x squared plus 2x plus 6. This is over x squared times x plus 3. Now I want to see if this up here can be factored. So this is going to be a little complicated because I have something in front of my leading term, and I have two choices here. I could do 1 times 6 or 2 times 3. That's too many things to do guess and check, and I'm going to do the area method or box method. So let me go find a place off to the side. I'm going to draw my box. So up in my top corner, I put my first term. That will be my 3x squared. My bottom corner, I put my last term, and that's going to be 6. I'm going to multiply those together, and that is going to give me 18x squared. So now I need things that multiply to 18 and are add to give me 2. So let's think about that. Our options for 18 are 1 and 18, 2 and 9, 3 and 6. There is nothing here that is going to add to give me 2. And what that means is that this doesn't factor. And if that doesn't factor, we can't cancel because there's no cancellation without factorization. And that means that this is our answer. Moving on. This is a little bit tricky, and remember, this is kind of what we expect to see. We have our x out front here. We don't. But I'm looking at these two denominators, and they look so similar, except for that thing. So let's do the trick where we multiply by a -1. So here, this would stay the same. So I have 3 over x minus 5 plus 4 over. Now I'm going to factor out a negative, and that is going to give me an x minus 5. Okay, now this negative, right, that's just a -1 times it. So we can either make this a -4 or we can turn that into a subtraction, whatever works for you. I'm going to move it up to the numerator. So this is going to give me 3 over x minus 5 plus -4 over x minus 5. Now I have a common denominator. So this will be 3 minus 4 over x minus 5, and that is -1 over x minus 5. Now, if you had written that as -1 over x minus 5, that would be fine. Or if you wanted to get like super fancy and write that as 1 over 5 minus x. Either of these is equivalent, but you know what? That's just more work. Why would you do that? We're going to leave it the way it is. But if I see those other versions of that on a test or quiz, I'm going to know it's the same thing, and you will receive full credit. So don't be afraid to do that. You just don't need to.